Hi, welcome back to Equations Involving Fractions. I've been scribbling here for you. Let's have a look at what's in the circle. I think of a number, not that again. I double it and add 3. Then I divide by that same number plus 1. Oh, this is getting complicated. And my answer is the fraction 5 over 3. Do you want to have a go? Let's see what we can do with it. So I think of a number. So let that number be x. So let's do that now. Let the number be x. Okay, so we're ready to go. I double it. That's 2x. And then I add 3. There we go. So we're down to here now. Then I divide by that same number. So that's x plus 1. So, I'm doing this, and the answer is a fraction 5 over 3. Question is, can you solve that puzzle? And that's what this next presentation's about. Let's go down. I think we've got that one right here. Oh, there it is. It's my first one. Remember, these are mine, but you can do them if you want, and these are yours. Okay, so do you want to start and see what we come up with? Okay, so we saw how this equation was produced from our little puzzle. So can we do it? Well, it's got fractions, so we want the common denominator again between these two. So usually we'd multiply them together. So here let's multiply top and bottom of this side by 3, and over here, top and bottom of this side by x plus 1. Oh, getting big now with that multiplication there. But remember, x is just another number. So let's do it now. Over on this side, we've got a denominator of 3 times x plus 1. And in the top line now, we have 3 times all of 2x plus 3. So it's 3 times 2x is 6x, plus 3 times 3 is 9. We're not fazed now by these bigger expressions. Over on this side, 3 times x plus 1, always using a bracket, 3 times x plus 1. And in the top line, 5 times all of this. Let's use a bracket again. So it's 5 times x is 5x, plus 5 times 1 is 5. Now, can we check out the denominators? Yes, they are the same. So if the fractions on either side are going to be equal, then their numerators or the top lines must be the same. You're getting pretty good at this. Okay, so there we have our next statement. And of course we want to collect all the x's up. Let's put them on the left hand side. So this is plus 5x, so we will from before do the opposite. Let's subtract 5x from both sides, and if we do that over here, subtracting 5x, then wipe out, those x's will disappear. Over here we've got 6x, take 5x is 1x. We don't use the 1 usually, just call it x. And the 9 is still there, equals, over on the right, number 5. Now x has had 9 added to it. To get x back again, we'll subtract 9. So 5 take 9 is negative 4. So, are you happy with that? Are you happy with these big expressions up here with x? Remember, x is only a number, so x plus 1 is only a number. In fact, 2x plus 3 is only a number. So what we're trying to do now is to really build up our ability to work with any types of numbers using x. Let's have a look at yours over here now. Your first one is here. So you want to pause me now and have a go. All right, coming back, we're going to use a common denominator. Here, let's multiply these two together for our common denominator. So over on this side, multiplying top and bottom by 3. And over on this side, remember, 2x take 1, it's just a number. So it's 2x take 1 over 2x take 1. let's see what's happening now. Our denominator here is 3 lots of 2x take 1. That looks good. Now we need to multiply this 3 by this, so using a bracket, it's 3 by x, it's also 3 by 3 is 9. Equals, over on this side, our denominator, yes, we have done it, we've got the same or common denominator. And now it's 1 lot of 2x take 1, so 1 lot of anything leaves it unchanged. Checking the denominators, yes, they are the same. So to keep the fractions equal, the numerators or top lines must be the same. Are you getting used to it? Can you see it? So now moving all terms across to the left, this is positive 2x. So let's subtract 2x from both sides. And if we do that, over on this side, what have we got? Wipe out. It reverses that. And so we have removed the x's. Over here we've got 3x take 2x is 1x. Remember, we don't usually write the 1. And 9 is left there. Equals, over on this side, neg 1. 9's been added to x, so if we take 9 away from both sides, neg 1 take 9 is neg 10. You can write that in neg 1 take 9, but you can do that in your head if you want to. Alright, let's go down. What's my next one? Do you want to do it before I do it? This one here. Okay. If you want to do it, pause me, because I'm going to do it now. We have 2 denominators here, common denominator, multiplying the 2 together. So we want to make a denominator of 5 times 1 take 2x. So over here we'll multiply top and bottom by 5. And over here multiplying top and bottom by the other denominator. Remember, 1 take 2x is just a number. Okay, so in our denominator here we're going to have 5 times 1 take 2x, and that's going to be over here, and 5 lots of x plus 1, so it's 5x plus 5, multiplying in there and in there by the 5, equals, over on this side, what's our denominator? These two, 5 times 1 take 2x. And in the top line, 2 lots of all of this. So 2 lots of 1 are 2. 2 lots of neg 2x, neg 4x. Do the denominators check out? Yes, they are equal. So for the 2 fractions to be equal, the numerators must be equal. So let's look at those 2. Now we want to collect all x's up on the left-hand side. So what's happened here? We've got subtract 4x, so let's add 4x. Let's do the opposite. So you'll see what happens now when we add 4x to both sides. And there it is. Yep, it wipes it out. Neg 4x plus 4x. Remember, x is just a number. So they are going to be equal to 0 overall. 5x plus 4x on this side is 9x plus 5. Equals number 2 left here. What's been done to x? Been times by 9. And then 5's been added. Unpack your present. Let's reverse those steps. Let's subtract 5 from this side. We're left with 9x. Subtract 5 from 2. 2 take 5 is neg 3. Dividing them by 9, x will be neg 3 over 9. And we can cancel by 3's. So this will be neg 1/3 for our answer. Fair bit of work in these as you get bigger expressions in the numerator and the denominator of the fraction. But this is as far as we have to go. You're coming very close to the end now, a very high level here in working with fractions in equations. So are you ready to have a go at your next one over here? So you can pause me now and have a go. Coming back, let's look at these 2 denominators. Let's go through the same steps now. Our common denominator will be obtained by multiplying top and bottom by our 4 from over here. And then on this side, remember x is only a number, so 4 take 3x is also only a number. So we're going to multiply top and bottom by that rather complicated looking number over there. And what are we going to have? This is going to be the new denominator on this side, 4 take 3x. And in the top line, the numerator, it's 4 lots of 2x take 1. Shall I do it in full this time? I'll write it out in an extra line perhaps. And over here, same denominator, and this time it is that negative. We've got to put that negative there with the 3. Lots of 4 take 3x. So put in an extra line now so you can check out what's happening. Let's look at the top lines now. It's 4 by 2x is 8x. Take 4 by 1 is 4 equals, now neg 3, watch this, neg 3, negative times a positive 4 will be a negative 12, and neg 3 times neg 3x, and negative times a negative is a positive, so that's going to be plus 9x. Let's collect up our x's again. So this is plus 9x, so let's subtract 9x from both sides, and let's see what happens. Do we get wipe out? I think we do. 9x, take our 9x, that's why we did it, doing the opposite step there. So over here, 8x, take 9x, is neg 1x, we usually leave the 1 out. Neg x, we've still got the neg 4 there, equals neg 12. So what's been done to x? So find x again. So here it's been multiplied by neg 1. So it's been multiplied by neg 1, and 4 has been subtracted. Let's unpack our present. Let's add 4 to both sides, and that will wipe this one out. And over on the other side, adding 4 will give us neg 8. Then dividing both sides by neg 1, we'll have x equals 8. So, not bad. Are you getting better at this? Are you happy? You might have to pause the presentation, go back and just check out all the steps perhaps to make sure you're confident. Okay, so we just come down here and have a look at these next couple. Alright, so my next one is over here. Do you want to pause me and have a go? Well, let's have a look at it. Oh, we've got a number added here. So, well, shall we remove that number? Let's take 2 from both sides so that we just get back to our work with fractions. That's not a bad idea. So if we take 2 from that side, it will disappear. Taking 2 from 3, neg 3 take 2 is neg 5. Now because we're working with fractions, we might call this neg 5 over 1. So that both sides can be seen as fractions. That's not a bad way of going about it. Now, of course, to get a common denominator, we'll leave this denominator as it is and simply multiply top and bottom by this number. Remember, x is a number. X take 1 is a number. So we multiply top and bottom by this number, x take 1. What will happen? Let's do this side first here. We will get neg 5 over x take 1. So there's no need to do anything to this left-hand side denominator. Let's leave it as it is, 2x plus 5 over x take 1. The denominators check here, so let's put the top lines and numerators equal to each other. Always keeping up the same mathematical process or notion that if two fractions are equal, and we see that their bottom lines or denominators are equal, it means their top lines must be also. So this isn't too bad. X has been times by 2 and 5 has been added. So we're going to reverse those steps. Let's take 5 away from this side, be back to 2x, and subtract 5 from this side. Neg 5 take 5 is neg 10. Then dividing by, reversing this multiplication by 2, dividing by 2, have neg 10 divided by 2 is neg 5. Remember, a negative divided by a positive is a negative. Alright, well, we're going well. Do you want to pause me so that you can have a go at your next one? Well, coming back, as you can see that we've got the same sort of idea here. If we were to take 3 away from both sides, we'd be left with a fraction on this side, and 4 take 3 would be 1. Let's call it 1 over 1 because we're working with fractions, and this is a handy way of doing it. Now this denominator is x plus 3. Working with fractions, we want to make the two denominators equal. So how are we going to do it to this one? Oh yes, we could multiply by the number x plus 3 on x plus 3. Remember, x is just another number. Oh, and so x plus 3 is also just another number. So over on this side, nothing's happened to this fraction. We're happy to leave it like it is. And then on this side, we have, yes, that common denominator again. That checks out. That's good. And in the top line, one lot of x plus 3. So that's just going to be x plus 3. Now this one doesn't look too bad. The two fractions are going to be equal. The bottom lines are equal, then the top lines or numerators must be equal. And there we go. X plus 1 equals x plus 3. Ooh, this is interesting. Is that possible? I don't think that's possible. Let's just observe that. I don't think it's possible to have any number x so that when you take 1 away from it, it's the same as adding 3 to it. Let's see what happens if we go through our normal procedures. Let's subtract x from both sides. X take 1, take x. And over on this side, take x. Wipe that out. Oh, it wiped this one out as well. What did we get? We get neg 1 equals 3. So often in equations, if it's not possible to find a number that's going to make the equation work, or make both sides equal, we will get a silly statement. Neg 1 is not equal to 3. This is impossible, so we write that down. We have come to an impossible situation, and that implies there is no solution. There is no possible number to do what we have proposed. And what did we propose up here? In words, we're proposing that when you add 3 to the fraction created by taking 1 away from a number and dividing by 3 plus a number, you should get 4. That's a word puzzle, I suppose, going backwards up there. And you can't solve that puzzle. There is no number that you can think of that will have that result. Interesting. Getting a bit more sophisticated now. So let's go down now and have a look down here. We've only got a few more to go. Let's have a look at this one here now. And my next one, remember you can pause me. Anyway, moving on now, look at the denominators. I think what we will do is we'll leave this one alone and multiply top and bottom of this one by 4. Let's leave the other side for the minute so that we've got x over 8 and this one's going to come to 8. So there's 4 lots of all of this. So that's 4x. 4 times the x and 4 times the 2, that's 4x plus 8, all over 8, equals, now, we've got a whole number which we'd normally call neg 1 on 1. Because we're working with fractions, let's bring in a denominator, so let's multiply that one, top and bottom by 8, because then what have we got? We've got x plus 4x plus 8 on this side, all over 8s, and here we've got neg 1 times 8 is neg 8 on 8. Alright, so if we collect these up now, x plus 4x is 5x, the top line there is going to be 5x plus 8, and it will be equal to the top line over here, which is neg 8. What's been done to x? Been times by 5, and 8's been added. So let's reverse that. Let's subtract 8. So we'd have 5x on this side. Neg 8, take another 8, is neg 16. Then dividing by 5, reversing that step, we would have neg 16 over 5. And we could call that again the mixed number neg 3 1/5. All right, a bit different looking that one. What about yours? Here we are, yours is over here. You want to pause the presentation and have a go. Let's look at the best denominator to use to make them the same. Well, can you see, all we really need to do is multiply this side by 3 over 3, because 3x would then be over 6, take x over 6 equals, let's call 4 over 1. So we're working in fraction land right the way through. So that was quick. We made our common denominator here fairly easily. Well, we haven't done it for this side, so maybe we'll just multiply by 6 over 6 there. Let's have a look at what this one is over 6. 3x 6, take x, 1 lot of x over 6 is 2x over 6 equals 4 by this, 24 over 6. Now that came out quite neatly. Now we can say the denominators check out, so the numerators must be equal. So we have 2x equals 24, x would be 12, reversing that multiplication of 2 lots of x to come back to find out what x was. All right, we've got a few more. Let's come down and have a look at these now. So here is my next one. So do you want to pause me and have a go? All right, well, coming back, we can see 3 and 6. So I'm just going to work on this fraction over here. Because if I multiply top and bottom by 2, I can make it the same as this 6. So let's do that. 2 times all of this is 4x take 2 over 6. Take 5x take 6 over 6. And let's change this to -2 over 1, and changing that to 6 as well. There we have it. Let's now collect them up. All over 6 on this side would be 4x take 2, that number, and we must subtract the whole of this number here. So let's use a bracket, because this number, remember x is just another number, is coming in an x part and a part with an ordinary number 6 in it. So we have to subtract the whole thing. So the bracket is a good idea. And then -2 times 6 is -12 over 6. Let's look at the left-hand side top line now. This is 4x take 2, take 5x, and take -6. A negative times a negative is a positive. And over on this side, we have the top line of -12. It's coming along. Collecting up our x's, 4x take 5x is -1x, or just -x. -2 plus 6 is +4, and that equals -12. So what's been done to x? I see it's been times by -1. Then we've got 4 has been added. So let's reverse that now. Subtract the 4 from both sides. We're left with -x here. -12 take 4 is -16. Divide both sides by -1. You would have x is 16. All right, not bad. Fair bit of work. Oh, you've got one over here. You've got one over here. Look at the denominators. This one's not so easy. Well, I think you're going to have to do something to both fractions here to get a common denominator. Do you want to pause me? Have a go. Well, coming back, we said, yeah, well, the common denominator here is probably best done as a 12. So we've got some work to do. 4 over 4 here. And times it here by our x plus 2 over 3. And then adding, what are we going to do here? We'll multiply top and bottom by 3, being careful here. And over here, well, this is 1 over 1. We want it over 12. It looks like we're going for 12s here. Let's see if that works. We're going for 12s, aren't we? So this is 12 in the bottom line. 4 lots of all of this number. Remember, x is just another number. x plus 2 therefore. It's just another number. We multiply it by 4, it's got to be 4 lots of x though, plus 4 lots of 2 is 8, plus, here we have over 12, there we are, and 3 lots of all of this number. 3 lots of x is 3x, and then 3 lots of neg 3 is neg 9. And over here, 1 by 12 is 12, and 1 by 12 here. So it looks like we have done it. We've got all the bottom lines or denominators the same. Let's look at the top lines now. So 4x plus 8 plus 3x take 9, that will be our 12ths, our total 12ths, won't it? We had this many 12ths plus this many, remember, x is only just another number, and so this is 12 over 12. So let's collect the numbers up now. We have 4x and 3x is 7x, and 8 take 9 is neg 1, equals 12. Equating the numerators, or putting the numerators equal. What's been done to x? It's been times by 7, and 1's been subtracted. Reverse those steps now, add 1 to both sides, and we'll get 13 over here. Divide both sides by 7, we'd have 13 over 7. And remember, as a mixed number, 7 into 13 goes once, and 6 over, so it's 1 and 6/7. Are you having fun? It's getting fairly complicated, but this is the highest level, and you're doing well. Stick with it. So let's have a look down here. We just bring this down a little bit further, because what we need is these last ones. These are our very last ones. Oh, can you see that they are a little bit more challenging? Have a look at mine over here. And, well, we've got our denominators. You can see probably 10's a good one, and we could make the 5 into a 10 and the 2 into a 10. But can you see what is happening here? We have 3 fractions. So this could become monstrous. You might like to make up equations with 4 fractions and see if you can solve them. So if you can do this one, you can do anything. So do you want to pause the presentation now and have a go at my first one? Right, maybe not. So here, let's make all of the denominators over 10. So this one we're going to multiply by 2 over 2. And if we do that, it looks like that. This one we're not touching, because already it is a nice denominator to make as a common denominator with the other ones. So here, x take 1 over 2, I want to make that over 10, so I'm going to multiply top and bottom by 5. Now let's have a look. Did it work? Yes, that's a 10. And now in the top line or numerator here, it's 2 lots of this number. So it's 2 lots of x, take 2 lots of 6, which is 12. Then we're going to take away this number on 10, and it's going to equal bottom, oh yeah, that checks out, that's over 10 as well. And now it's 5 times this, so it's 5 times the neg 1, and it's 5 times x. Let's do the x first. 5 times x is 5x, take 5. So we've done it. All the bottom lines are the same, so let's group them up over here. How many tenths have we got over here? We've got 2x take 12 tenths. Take away this number, or we better put that in brackets. It's got 2 parts there. And so there we are. We have this many minus this many tenths equals this many tenths. All right, what can we do then? Well, let's collect them up over here. 2x take 12. Now this is take 2x, and then we want to take neg 1. So that's negative times a negative is a positive. So that's the resulting top line over there, and that will equal the top line over here. So let's tidy up. 2x take 2x, oh, wipe out. Okay, we've got no x's left, but neg 12 plus 1 is neg 11, and that has to equal 5x take 5. So what's been done to x? Been times by 5, and then 5's been subtracted. Get x back again, you'll add 5 to both sides. Neg 11 plus 5 is neg 6. Do you need to check that on the number line? And then adding 5 to this side, we'll leave that at 5x. It wipes out this 5 if we add 5 to the side. Dividing now by 5, we get neg 6 over 5 equals x. Or you might like to write that as the mixed number neg 1 1/5. Okay, a big one. Now, here's your last one, and then you can take a rest and wait for the next presentation. Okay, do you want to pause me? Might do that now. Okay, so coming back, looking at these three denominators, can you think of the smallest one that they would both go into? If you just multiply them all together, you'll get much bigger numbers to work with. So it pays us to see if we can find the lowest common denominator. I think you can see it. It's 12 here, isn't it? Yeah, it's 12. So let's make them all into 12ths. So we have to multiply this one by 3 over 3. And then take away 12ths here. I have to multiply this one by 6 over 6. So let's just put that there. Notice I've used a bracket there. And then this one will multiply by 2 over 2. That will give us all 12ths. Let's check it. Yes, that's 12ths. Now it's 3 times, I need to put a bracket there, 3 times 2x is 6x, plus 3 times 1 is 3. Then we're taking away, yes, we've got 12ths, it worked, there. And now 6 by 1. Okay, so what we'd better do is we'd better bracket this. We'll just leave it for the minute and see what happens. 6 times 1 is 6, and 6 times neg 4 is neg 24x. Got to remember, though, to take away all of that in a minute. So here, have we got a common denominator of 12? Yes. And it's 2 lots of all of this. So it's 2 lots of 3x is 6x, plus 2 lots of 7 is 14. Let's collect all the terms up over here, all over 12. How many 12ths have we got? We've got 6x plus 3 12ths. Remember, x is just another number, so 6x plus 3 is just another number. And then we want to take away all this number here, which is 6 take 24x. Because it's got a negative in here, we better be careful to put in a bracket. And that's got to come to 6x plus 14 on 12. Right, so bottom lines are the same, so we can just look at making the top lines the same. So let's do this now. Take 6, neg 6, and then take negative 24. Negative times a negative is a positive. So it's plus 24x equals 6x plus 14. Okay, let's collect up the x's. 6x plus 24x is 30x. Now collect up the numbers. 3 take 6 is neg 3 equals 6x plus 14. Okay, let's collect all the x's on the left-hand side. So it's plus 6x here, so let's take 6x away. If we take 6x, we will be left with 14 over here. So let's do it. 30x take 6x is 24x. Put that down. Take 3 equals 14. What's been done to x? It's been times by 24, and 3's been subtracted. So we'll go in reverse now. We'll add 3. 24x will equal 17. And then dividing both sides by 24, we get 17/24. Well, how did you go? What did you think of all of that? You've done a lot of hard work there, so you might like to go back and rewind the presentation and check some of those steps out, make sure you're happy. But for the moment, that's all we're doing, and we're going to come back and looking at further work with X and some multiplication with X terms in the next presentation. So have a rest now, and I'll see you then.